I don't know what I'm going to do. I do know I'm going to do something. The first line of the first lyrics of the fraction song says, adding fractions that you see match the bottoms perfectly. This works and explains what you must do for adding and subtracting fractions. Now, the first thing we're going to talk about are different kind of fractions here. They're like fractions. Those fractions have the same denominator. For our first example, we have like fractions. Now, the song says, adding fractions that you see match the bottoms perfectly. Well, I have a 2 as my denominator, a 2 as my denominator. So my answer, my sum, has to have a 2 as its denominator. The bottoms have to match. The denominators need to match perfectly from adding to sum. And all I do now is add my numerators. 1 plus 1 is 2. We said that any number divided by itself, 2 divided by 2 equals 1, so we can simplify this, and that becomes a whole, or 1. Okay? For subtraction, we see the same thing. We have 5 as a denominator, 5 as a denominator. It says match the bottoms perfectly, so that means that my difference has to have a 5 as its denominator. All the denominators match. All the bottoms match perfectly. And all I do now is I take my numerator and subtract my other numerator, and I end up with the difference of 1/5. That's the easy way. That's like fractions, and it works well with our song, adding fractions that you see match the bottoms perfectly. But we also have unlike fractions. Unlike fractions are fractions that do not have the same denominator. In our example here, we have 4/5 plus 4/7. The denominators do not match perfectly. These are unlike fractions. We have to figure out what our sum is going to have for a denominator. And likewise, for our subtraction, we have 8/9 minus 1/2. The denominators, again, do not match. Now, the first thing it says is adding fractions that you see match the bottoms perfectly. So here, to do these two problems, we have to find a common multiple. Most teachers say the least common multiple, and I agree that the least common multiple is what we really want to find. But if you can't find the least common multiple because you're still working on your multiplication facts, then you can find a common multiple, and later on we'll show you how to reduce the fraction anyway. So it says find a common multiple. Now you can use your multiplication facts. I can show you again how to use skip counting. You can skip count to find it. And for lack of a better word, I called it butterfly. And what you do there, I'll explain when we get there. All right, for our first example, in the addition, I'm going to just pull the subtraction off to the side. It doesn't matter. We have to find a common multiple. I know my multiplication facts. I can go 5, 10, 15, 20, 25, 30, 35. And I also know that 7 times 5 is 35. So I know that I have to multiply my 5 by 7. And I need to multiply my 4 by 7. Because when we find a common denominator, all we're really doing is renaming our fraction. Any number times 1 is itself, and 7 divided by 7 is 1. So we're just renaming this fraction. And again, over here, I know that I need to multiply. And notice on my sheet of paper, I'm not worried about the equal sign because I'm going to rewrite the problem anyway. Now I have 5 divided by 5, which equals 1. The ugly 1, which is this thing right here, reminds me that I need to multiply my numerator and my denominator by the same value so that I rename the fraction. 7 times 4 is 28, and 7 times 5 is 35. And I bring down my plus sign, and I like to work directly up under so I can make sure that I'm following what I need to find. 4 times 5 is 20, and 7 times 5 is 35. The song says, adding fractions that you see match the bottoms perfectly. Well, we just matched the bottoms. 35, 35. My sum has to have a denominator of 35. That's using our multiplication facts. We constructed an ugly 1. We multiplied our numerator and our denominator by the same thing. We multiplied our numerator and denominator by the same thing here. That's using multiplication facts. We can find out that our answer is 48. And we can simplify by doing the math, and that would mean 48 divided by 38. But before we do that, because I'm not really talking about simplifying yet, we'll do that in a minute. I want to show you skip counting. Skip counting, I would probably start off with my 7. And I go 7 plus 7 is 14, plus 7, 7 plus 4 is 1, carry my 11, carry my 1, 1 plus 1 is 2, 7 plus 1 is 8, bring down my 2, 7 plus 8 is 15, plus 2 plus 1 is 35, and I'm going to stop there because it just proves that I can skip count. I can skip count as far as I need to. And then I can skip count with my 5. 5, 10, 15, 20, 25, 30, 35. And then I notice that that's the common denominator. And to figure out what I'm going to use for my ugly 1, well, I go back to my 7. I count 1, 2, 3, 4, 5. So my ugly 1 has to be a 5 and a 5. And then I check over here with my 5 and I go 1, 2, 3, 4, 5, 6, 7. 5 times 7 is 35. So my ugly 1 needs to be a 5 here. And the benefit of that is I already know what my ugly 1, I already know what 4 times 5 is going to be. 4 times 7, because I go 1, 2, 3, 4. That gives me my 28. I know what 4 times 5 is because I go 1, 2, 3, 4, and that gives me my 20. I still have the same thing. For those of you who know your multiplication facts, I could also go 7 times 5. This is the butterfly. I do 5 times 7, that gives me 35. And then I do 7 times 4, which gives me 28. And then I do 5 times 4, which gives me 20. Listen, I don't want to confuse you. Watch it as many times as you need to and pick the method that works for you. Whether you know your multiplication facts and whether you want to do the butterfly, the X, the butterfly looks like this, by the way. And then here, and then here. Okay, and you multiply. That's the butterfly. It doesn't matter which method you use. What matters is that you're comfortable and that you understand how to use each method. Now, the last thing before I go on to the subtraction, we do have an improper fraction, and we want to simplify that. And we're going to take 35 and make that our divisor, and we're going to take 48 and make that our dividend. And remember, we're not going to convert this to a decimal. We're going to keep it as a fraction because it was presented to us as a fraction. We know we can't get 35 out of 4. But we can get 35 out of 48. And I believe we can only get it one time. So 1 times 35 is 35. And then we subtract. Just do the math. 8 minus 5 is 3. 4 minus 1 is 1. I take my quotient. This is my quotient. This is my remainder. This is my divisor. I take my quotient. I use my remainder, my divisor. So this is going to equal 1 and 13 over 35. That's what that equals. All right. Hope that helps. I didn't say I was the neatest mathematician, but I do try and keep it pretty neat. All right, on the subtraction side, we have the same thing. Multiplication facts, I'm going to do it with skip counting first. I'm going to start off with my 9. Okay, 9 is an odd number. 9 plus 9 is 18. A little bit of multiplication facts. 18 is an even number, so that means that 2 can go in 18 evenly. So knowing that, I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, 18. I have my number. 1, 2, that tells me I got to multiply my 9 by 2. What I do to my denominator, I have to do to my numerator. So I set up an ugly 1 that has 2 times 9, 2 times 8. 2 times 8, well, 1, 2, 3, 4, 5, 6, 7, 8. 2 times 8 is 16. And 2 times 9 is 18. So I have half my problem done. And then I know I have to do, to get to 18 with the 2's, is 1, 2, 3, 4, 5, 6, 7, 8, 9. So I need to have 9 as what I'm multiplying my denominator by, and 9 is what I'm multiplying my numerator. Again, that's the ugly 1, because that's not how we normally see 1, but 9 divided by 9 is 1. 9 times 1 is 9, and 9 times 2 is 1, 2, 3, 4, 5, 6, 7, 8, 9, 18. We have a common denominator. Adding fractions that you see match the bottoms perfectly. So I'm bringing my 18 over. So my difference and my numbers I'm subtracting, those are all the same. Match the bottoms perfectly. 16 minus 9 is 7. And 7/18 is our answer. All right. The second stanza, or the second verse of our song says, multiplying fractions, no big problem, top times top over bottom times bottom. Multiplying fractions, no big problem, top times top over bottom times bottom. What that means is simply numerator times numerator over denominator times denominator. Multiplication of fractions is essentially easy because all you do is multiply across, multiply across. The fraction song got from Miss Terman at Thompson Middle School in Georgia, and multiply across I got off a video that I saw on YouTube. Either way works. Top times top over bottom times bottom. The numerator times numerator over denominator times denominator. 15, 5 times 3 equals 15. And forgive me if I'm not skip counting this time. You certainly can, but we're working on a time thing. All right, 9 times 4. Well, I can go 9, 18, 27, 36. 1, 2, 3, 4. That's 36. We'll talk about simplifying this in a minute. Let's do another example, and we'll show you how to simplify at another time, simplifying fractions. All right, example number 2. And as you can see, I'm making it up right now because it's so easy. It's 4 sevenths times 2 thirds. 4 times 2 is 8. 7 times 3 is 21. We just multiply across. Another one. 3, we have negative 2 thirds times negative 4 fifths. Yes, you can have negative fractions, and yes, you need to know your integer rules. Negative times a negative equals a positive. The 2 pair of negatives cancel out. 2 times 4 equals 8. And 3 times 5 equals 15. What I did was I looked at the negatives first, but you can do the math first and then decide later. But the 2 negatives cancel each other out. Remember, I said when we have negatives, it tells you to go in the negative direction. And then when you see the next negative, it changes direction, which is why the 2 negatives in multiplication equal a positive. All right, that's multiplying fractions. I don't know what I'm going to do. I do know I'm going to do something. All right, the last part of the fraction song says, dividing fractions easy as pie. Flip the second and multiply. And I've written out my example here. And I need to tell you that the word flip means to find the reciprocal. To find the reciprocal. And all a reciprocal is the number that a fraction has to multiply it by itself to equal 1. So what fraction can we multiply 15 sixteenths by and it still equal 1? Well, this also points out cross cancellation. I can multiply across. I can do 15 times 16. So I'll do that right here. And I'll do my math. And 15 times 16, 6 times 5 is 30. So I'll bring down my 0, carry my 3. 6 times 1 is 6, plus 3 is 9. And then bring down my placeholder because now I'm working in the tens place. 1 times 5 is 5. 1 times 1 is 1. I add these two together. I get 0. I get 14. Carry my 1. I get 2. 240. Well, if this is 240, then this is 240, and this is 240. So the reciprocal of 15 sixteenths is 16 fifteenths because the reciprocal is the fraction I can use to multiply my fraction with and get 1. And 240 divided by 240 equals 1. Having said that, the song makes it easier. All we did to find the reciprocal, if you compare the two, this is the original fraction. This is the reciprocal of that fraction. My denominator has become my numerator. My numerator has become my denominator. So the song says flip the second. That means we keep the first fraction. It says flip the second. So let's go ahead and flip the second. Make our denominator our numerator our denominator. And then it says multiply. If you want to follow the song step by step, you can. It says flip the second. Well, we flip the second, then multiply. Do your multiplication, and there's only one thing left to do with the original fraction or the first fraction. You bring it down. Then we go back to where the song says, multiplying fractions, no big problem. Top times top over bottom times bottom. Again, let me do my scratch work, and I can set it up as a regular multiplication problem, even if I know I'm going to have to skip count, because watch this. I can still skip count with my 7s. 7 and 7 plus 7 is 14, and plus 7 is 21, and plus 7 is 28, and plus 7 is 35, and plus 7 is 42. I may be working faster than you, but you can check my math. Plus 7 is 49. 1, 2, 3, 4, 5, 6. 7 times 6 is 42. Okay? I'm moving over to the tens place. I need a placeholder. So 7 times 1 is 7. I add those two together. I get 2. I get 8, 9, 10, 11. 111. Excuse me, 112. So I can set my problem up, and I don't have to skip count 16 times. I can just skip count my 7 and then find the 6th one. 1, 2, 3, 4, 5, 6. Write down that answer and then put my placeholder in and then skip count for that value, which is 7, and put that in and add, just like I would if I knew my multiplication facts. So you can use skip counting in different ways. So I have 112, and now I have 8 times 15. Well, I'm going to do my 8s. Let's do 8, and then 16, and then 24, and then 32, and then 40, 48. How many spaces do I need to go? Well, it's 8 times 15, so I only need to really go to my 5s place because that's a higher number. So I'm going to set it up. 8 times 15, 1, 2, 3, 4, 5. Well, 8 times 15, 8 times 5 is 40. Placeholder, go to my tens place. 8 times 1 is 8. Add that together, 0. I get 12. That's 120.